Morning. Myself Prabharan J, working as a assistant professor in EC department at SNS College of Technology. In this lecture video, I am going to discuss about the sectioned convolution from Unit 1 in DSP subject. Okay, let me discuss. Okay. Sectioned convolution. Empathy of this topic is difficult to filter long data sequence and filtering of long data sequence is slow. Sectioned convolution, the response of linear time invariant system for any arbitrary input is given by linear convolution of the input and the impulse response of the system. The sectioned convolution, also known as block convolution or partitioned convolution, is a technique used to compute the convolution of two sequences by breaking them into smaller segments of blocks. This approach is particularly useful when dealing with long sequences or when memory limitations prevent the entire sequence from being processed simultaneously. The basic idea of sectioned convolution involves dividing the input sequence into smaller blocks, computing the convolution for each block independently, and then combining the result to obtain the final convolution. Here we are using two methods, that is overlap save method and another one is overlap add method. Okay. Here we are using two methods, that is overlap add method and another one is overlap save method. In overlap save method, the total sequence is divided into smaller block. Okay, if the length of the new data, we can assume the length of the new data, that is whether it is L equal to 3 or else L equal to 4, whatever. Okay, the subblock, front side of the subblock have m minus 1 zeros and right side of the subblock have m minus 1 previous data. Here m is nothing but the length of the impulse response and ls is nothing but the representing the length of the input sequence x of n. Okay, total length of the input sequence x of n is represented by L suffix s, and length of the impulse response is represented by small m. Okay, small m. Okay, and subblock, the length of the new data is nothing but the L. This value we can assume this value, and length of the subblock n equal to L plus m minus 1. Okay, here we can see x1 of n is one of the subblock, x2 of n is one of the subblock, x3 of n is one of the subblock. So the front side of the x1 of n, that means left side of the x1 of n, add m minus 1 zeros. If it is m equal to 3 means 3 minus 1, that is 2 zeros, add 2 zeros from the left side of the x1 of n, and in right side of the x1 of n have m minus 1 previous data. Okay. Similarly, x2 of n and x3 of n. See, And finally we can get for x1 of n we can get y1 of n output, for x2 of n we can get y2 of output, for x3 of n we can get y3 of output, right, in this manner. Okay. First m minus 1 data, eliminate the first m minus 1 data from the output sequence, respected output sequence. Okay, for x1 of n y1 of n, for x2 of n input sequence y3 of n, for x3 of n input sequence y3 of n. First m minus 1 data, remove the first m minus 1 data from each and every output for subblock. Okay. And finally write the remaining output. Okay, this is the steps for overlap save method. First we have to add m minus 1 zeros from the subblocks, and finally end of the sequence we have to add m minus 1 previous datas. And yeah, see, you can see the diagram here. First m minus 1 data, discard the first m minus 1 data from each and every output for subblocks y1 of n, y2 of n, y3 of n. And overlap add method, this is the another method for sectioned convolution. In this method we have to add m minus 1 zeros end of the each and every subblocks. Okay, x1 of n, end of x1 of n have m minus 1 zeros, end of x3 of n have m minus 1 zeros, end of x3 of n have m minus 1 zeros. Finally we get the each and every subblock, we get output for each and every subblock, like y1 of n, y2 of n, y3 of n. Write the output in this manner and add the m minus 1 datas like this. From first output we can add m minus 1 datas from the second output. You can see a diagram. In this manner we can write each and every output and add the m minus 1 datas. Okay. Yeah, this is the difference between overlap add method and the overlap save method. Linear convolution of each section of longer sequence with smaller sequence is performed. Circular convolution of whereas overlap save method was circular convolution of each section of longer sequence with smaller sequence is performed. Zero padding is not required for overlap add method. In overlap save method, zero padding is required to convert input sequence to size of output sequence. The overlapped samples in output are added to get overall output in overlap add method. In whereas overlap save method, in the output the last n2 minus 1 sampling or first n2 minus 1 samples are discarded. Okay. Yeah. Okay, if you have any doubt you can ask me through the comment. We will meet in next video. Thank you.